Welcome to the We Love Open Source podcast. We have a special guest today. So welcome, special guest. Why don't you tell us who you are?
Sure. So my name's Lee Faust, and I am the CEO and founder of Atomic Software.
All right. What is Atomic Software?
So Atomic Software is made up of two different products. We are building a brand new version control system that is built from the ground up with the intent of artificial intelligence and working with agents. There's another product that is called Circuit Breaker, which is a different type of workflow using something called petri nets, allowing us to be able to run what we call mini pipelines against every change that's being impacted by the agents.
So I guess there's a reason it's called Circuit Breaker. What is the Circuit Breaker function? What's the value of that?
Yeah, so petri nets go way back. There's a lot of studies. So petri nets are based off of like a stoplight, and you have different states. Mm-hmm. So everybody knows what the states are: red, yellow, and green. Mm-hmm. And when you come to an intersection, you know what those states mean. But then you start to be able to impact other things, like what happens if I have a crosswalk, or what if I have a left turn signal, or all of those different things start to build and model a very complex network of different states. So what happens is traditionally with normal CI jobs or with pipelines, you have to wait until a change is pushed to a server, and then you run the entire pipeline. Mm-hmm. Well, what if there's 20 steps in that pipeline, and it was step 19 that failed? Mm-hmm. Everything before it was perfectly fine. So I built my Docker image, I had everything correct, but my manifest for Kubernetes was wrong. Well, do I really want to go ahead and rerun the entire pipeline again just to change the state for the Kubernetes change that I need in the manifest? Mm-hmm. So what if I could just change the manifest, take the Docker image, and just reapply the manifest after that state? So now you can break up jobs as states, and at any point in time, you can break the circuit by being able to say, I failed, I can stop, walk away. I can either restart it and reintroduce the precursor to be able to make that work. Or the other thing is I can just go ahead and drop it and then start from the beginning again. So being able to give you that type of optionality that we don't get with today's pipelines.
Great. So today, the most popular source control is Git, and that was a product of Linus Torvalds, who wrote Linux, scratching his own itch. I think he was using BitKeeper, and the licensing changed.
Correct.
And so I don't want to be ageist, but I see that you have a little bit of gray hair like myself, and it sounds like those opinions have been formed over many years. So why don't you give a little bit of the background of what led you to start Atomic and what problem you're trying to solve?
Yeah, so I am actually basing Atomic from a version control system perspective off of another open source project that I ran into 4 years ago. And it is something called Pahul. And Pahul was done from a gentleman in France. He was doing his doctorate thesis on patch theory. And he built his own version control system to prove that theory. And we had multiple conversations over the last 4 years. And it was one of those things that just a lot of people, they were like, you know what, Git's good enough. Why would you introduce something now? Blah, blah, blah. And now with the whole thing around artificial intelligence, when I was at GitLab, I was seeing a lot of customers struggling with being able to run their merge requests through an agentic workflow. The scenario that I see, I've done a lot of work with large enterprises. So you could imagine if I have 1,000 engineers and each one of them spins up 100 agents to go off and build some stuff, that's a lot of merge requests that need to get reviewed in a very short period of time. And Git was always built for human-to-human collaboration.
Yeah.
So over the years, what I have seen is I've seen a lot of different ways to track change. So going all the way back to ClearCase and CVS and Visual Source Safe and Subversion. And what I wanted to do is I wanted to find a way to try to encapsulate a little bit of all of them, because each one of them had their advantages, but they all also had their disadvantages. And so if we think about building a brand new version control system today, what would we do if we envisioned a world where AI was as popular as it was? So that was the whole goal of building Atomic.
Yeah. So now we have human tasks being completed at machine speed, and we need a version control system that can keep up with that. And that's what you built, it sounds like.
Yeah, so I saw a really good video where what we've done is software development's always been linear. So the time that we would go from product management to testing to source code development to pipeline testing on the back end to delivery, they all sort of took about the same amount of time. And what we've done is we've built this hourglass effect. So now we spend a lot more time in the beginning by being able to build context, making sure we're prompting the AI, giving it skills, doing all these things with all the tools that we now have available to us. But then when we get to writing syntax happens like that.
Right.
And before, that used to be the longest part. You had to have formal training, you had to go to college, you had to know how different things and how different languages interacted with one another, understand how APIs worked, all these other things. So now that we've able to reduce what that looks like, we now need to figure out a way to then, on the other side of the hourglass, how do I validate that what I requested is what I got? And that's where that whole idea of the 1,000 engineers with 100 changes in a day, that's just really hard to be able to reflect what that looks like in the real world.
Nice. So if someone wants to see what you're up to, try things out, where can they find you?
Yeah, so we do have a GitHub repository. So it is under the organization. So it's atomic.dev spelled out. So the dot is DOT. And there's 3 open source projects in there. So we have Atomic is in there. We also have Circuit Breaker and then a docs page. So if you're interested in learning more about what we're building, where we're going, there's a bunch of examples in there. One of the big things that usually catches a lot of people off guard is when they look at Atomic is not only is it just version control, but we're able to do things like store AI provenance. We're able to build change records that are completely different than the way that you would do them in Git. Had a friend of mine that was actually joking when he was looking at the repo. He was like, this is really hard to read because I've already swallowed the red pill with Git. Yeah. So you almost need to do like you do with your AI today. Go in and say / ignore everything that we've talked about before, right, and let's start over again. So make sure if you go out and look at them, come at it from a brand new, fresh set of eyes.
That sounds great. Well, thanks for joining us on We Love Open Source, and good luck with everything at atomic.dev.
Thank you.
Have a good one.